Hello, yeah, hi. So today we will study about the structure of atom and the gravitation. So you see a lot of things every day, like a car made up of aluminum, a train made up of iron, or a coal through which we produce electricity. So this aluminum, iron, carbon, this is what we call the elements, and these elements have the properties of their own. Like aluminum is lightweight, iron is heavy and durable or strong. So today we will understand how aluminum came to be aluminum and iron came to be iron. So like if we start dividing these elements, I mean the aluminum and the iron into smaller and smaller pieces, we will come to a point where we won't be able to further subdivide it without releasing electrically charged particles. So, this particular state of the element is called an atom. Uh, you can technically further subdivide it, but that will release electrically charged particles. So, a good thing about this, not a good thing, or the property of the atom is that particular single atom still has the properties of that element. So for example, when you place a magnet near the iron, so iron get attracted towards the magnet, right? So if there is a magnetic force near the vicinity of that iron atom, that particular iron atom will still get attracted to that magnetic influence. So now that we have understood that what an atom is, now let's deep dive into what an atom is made up of. So like let's assume a ball. There is a ball, so that represents an atom. So inside that ball there are two major components. There are electrons and there is a very dense nucleus. So what nucleus is, let's assume there is a football field, and inside that football field there is football through which player play the game. So if the size of the football field is the size of the atom, then the size of the football itself is the size of the nucleus. So that's how small it is. And that nucleus contains two major particles, that is proton and neutron. So inside an atom there are three main components: electron, which revolve or rather orbit around the nucleus, and inside that nucleus there is proton and neutron. So neutron are electrically neutral, so they don't have any charge on them, and this proton is positively charged or plus sign that we write, and the electron is negatively charged. So there is a force between this nucleus and the electron revolving around them. So there is this balance of force which is keeping everything together inside the atom. Um, so that is, yeah, the main components of the atom is, and the number of proton and neutron which are present inside a nucleus is what we call as a mass number. So mass number is very like a fun thing. So depending on the mass number there can be isotopes. uh, what isotopes are, they are basically same element but they show some different properties, or rather deviate from some certain properties of that particular element. Okay, now we will move to gravitation. So we will only cover some fundamentals. So let's say there is a ball, not the representation of an atom, but actual cricket ball. So you throw the ball up. So what will happen eventually? That ball will go up, reach a certain height or the peak, and then it will start falling down. And if you take a bird feather, you toss it up, it will take a bit longer, but it will fall down eventually on the ground. So what is this thing that is causing the objects to fall to the ground? So that particular force is we call gravitational force, or in our case, the gravitational force of the Earth. So we can say that the gravity is the force of attraction between any two objects. Object A, object B, there is a force. They both are attracted towards each other. That is called the gravity. And in the universe, everything is getting attracted to each other. So let's say there is this Orion belt, is Orion constellation is in the sky. So that is like way too far away, like in the light years distance we are measuring them. But still there is a gravitational interaction between the Orion constellation, the stars of the Orion constellation, and the Earth. Though very weak it may be, but it is still there. So, how do we quantify that gravity? So, Mr. Newton already did that for us, and we have like a very established three laws of gravitation. So, we will cover one of them. So, it basically quantifies the force, the amount of force that is getting applied. Uh, so, what the law of gravity says that every particle in this universe is attracting every other particle, and the magnitude of that particular force is directly proportional to the product of their masses. So let's say there is object, this object A and object B. So these two, the magnitude of the force between these two objects will depend on the product of this mass of the object A and the mass of the object B. So if these two objects are very heavy, then the magnitude of the force will also increase. So like recently there was this satellite things go right. So they like spin around the Jupiter and then the slingshot. So why does it happen? Because of the gravitational pull of the huge planet. It is massive. The sun is like very massive, so it is like holding all the nine planets in our solar system together. And the second thing it depends on is the square of distance between the center of the objects. Object B, object A, they have their center point, center of mass. So this straight line between the center A and center B, so the square of distance between them. So basically, I mean, like farther the object are, the weaker the magnitude of the force is. Thank you.